the acceleration, then this right here would represent the acceleration on any planet. If you want to know what your acceleration of gravity is on any planet, this is how you calculate it. You use the mass of the planet, the radius of the planet, or anywhere in the, you're on an asteroid or you're near a black hole. This is what you use to calculate your acceleration, your local acceleration of gravity.
So then what is M1 for?
M1 is
That's-
the mass of whoever's being measured, like my mass or
okay.
the mass of the rock sitting there.
That's why, because it's not asking like with another, it's, okay.
Yeah, so
I
it's
get
asking
it,
for
I
the
get it.
weight. This would be the weight, right?
Yeah.
This would be the mass of
Weight.
the object you're measuring plus times thing. It's just asking for the acceleration.
Okay. Let me see.
You got it?
Mhm.
Okay. So number 5.
A coin is placed 13 centimeters from the axis.
I think I did this one in class, didn't I?
Yeah, it was just different numbers.
Yeah.
On a turntable. When the speed of the turntable is slowly increased, the coin remains fixed on the turntable until a rate of 38 RPMs is reached, at
Okay.
which point the coin slides off. What is the coefficient of static friction between the coin and the turntable?
What's the mass of the coin?
It is 13, it doesn't say.
Okay, and then what was the distance was 13, R was
13
13?
centimeters.
13 centimeters, okay. So, this is again one of those definitions here. So what we have, we have the force of gravity, right?
Mm-hmm.
We have the normal force, okay? We're gonna have the centrifugal force, and we're gonna have the force of friction. Okay? So in the up, down, like, when I draw it like this is the surface of a disc, right? So you imagine a disc is like this, so the normal force, force of gravity, and centrifugal force, and towards the center is the frictional force. So if we look at the top part, the up and down, the y, I guess is what we call it. So we have the sum of forces in the y direction is going to be the normal force minus the force of gravity. It's not leaving the disc up in the air, it's not going through the disc, so that means we assume it's going to be 0. You guys remember?
Do you remember why actually?
Yep. For your partner in crime. She's not coming?
No, she's not. She has a class or whatever.
Okay.
Yeah.
So that means that this implies that the normal force is equal to Fg, right? Which is our mass and the acceleration of gravity. Then if we look at the forces in this direction, the sum of forces in the radial direction, which is along from the center outwards, right? That's going to be the centrifugal force minus the force of friction. And if you get to the point where it's just about the maximum speed it can be, where it's just about to leave, like the maximum speed before it starts to move, then this is going to be 0, right? Just at the point where it's about to start sliding. Okay, so if we do this, that means that the centrifugal force is equal to the force of friction. Now what's the centrifugal force? The centrifugal force is mv squared v squared over r, right? And this is equal to mu times mg, right? So that's why I didn't have to give you guys the mass.
Yeah.
Okay? And it's asking what the coefficient of friction is? Is that what it's asking? Yeah,
yes,
right?
The coefficient of
Okay,
static.
static friction, right? So in here, now you have to remember this relationship. V, remember, was omega times r. You guys remember that?
We have to memorize that, right?
No, that's given.
No, it's not.
Oh.
You don't have to memorize any formulas. You just have to memorize methods, and not memorize, but understand methods.
So, we don't have to memorize, well, we do have to memorize that mu is like the force of friction, like the coefficient of friction.
You don't have to remember. It's a definition.
So all of that is given to us?
Yeah, it's
Yeah.
on the top there.
But one of them was like, okay,
Did you want to see
there
it?
was, no, it's okay, because there was something that wasn't given to us, but, okay, it's fine. Go ahead.
Well, the W wasn't there for the spring one, but I think you still.
Yeah, the spring
make it
one
up.
wasn't there.
No, but I'll give it to you guys. The spring one, I'll give it to you guys. I'll put it on the board. Don't worry about it. Yeah, you guys don't have to memorize any of that. So here, this omega, so if I square both sides here, this becomes v squared equals omega squared r squared, right? So I plug it back in here, I get omega squared r squared over r equals mu s g. Let me solve for mu. So my mu s static, this is the static coefficient of friction, that's why I put the s there. This is going to be mu squared r squared over rg, and of course the r's cancel like that. The problem is that this omega is in RPM, so we want to make sure we put the omega, because this is in meters per second squared, right? And this is in meters, so we want to make sure that the omega is in seconds, right? So our mu s is going to be, this guy's going to be 38 RPM repetitions per minute, right? So that means it's going to be 38 divided by 60, because there's 60 seconds in a minute, right? That's my omega. Squared times r. R is 13 centimeters, but we want that in meters because this is in meters squared, so it's 0.13 divided by 9.8. Okay? Okay, see what we did there? You see it? We just converted this from RPM to RPS, basically. Revolutions per second.
So that's 0.0053.
Did you actually calculate it?
Yeah, I did that one.
So, but you did it this way.
Yes, I did.
0.0053, which is rounded, right? It's like 2/7 something.
Mm-hmm.
Okay. And there's no coefficient here. Okay? It's just a number. You got it?
Mm-hmm.
Are you fibbing?